All right, welcome to lesson number 3. In this lesson, we'll be learning about the Fibonacci numbers in nature. All right, so here we have a statue of Leonardo of Pisa. Doesn't he look so handsome there? I mean, no disrespect, absolutely. This is a wonderful statue. I just love this. Then we have this vegetation here exhibiting 13 turns. And of course, we know the number 13 is what kind of number? Fibonacci is correct. And then here we have a cross section of an apple exhibiting a 5-pointed star, and the number 5, of course, is a Fibonacci number. And here they are lining the seed head of a daisy. I really like that close-up of the daisy. It's pretty awesome. All right, so let's carry on here with our lesson. And I am frozen. Why did that happen? No. No. Okay. Back to our show. What are the Fibonacci numbers? They are a sequence of infinite numbers. You can start with 0 or 1. So 1 plus 1 is, let me hear you say it, 2. 2 plus 3 we know is 5. 3 plus 5 is, that's right, 8. Okay, and the numbers, of course, as you remember, go into infinity. The numbers are frequently found in nature. Very exciting. And these numbers are named after Leonardo of Pisa. And I'm going to stop my webcam here because it's a little bit distracting. So Leonardo of Pisa, he lived from 1170 to 75 to 1240 to 1240 or somewhere between 1240 and 1250 AD. Leonardo of Pisa is usually called Fibonacci. All right, so who was Leonardo of Pisa? In 1170 to 1250 AD is when he lived. Ballpark years there. We're not exactly sure when he was born and when he passed, but it's within a 5-year range each for birth and death. So he was a mathematician born in Pisa, Italy. Other names of Leonardo include Leonardo Bonacci, known as Fibonacci, Leonardo of Pisa, Leonardo Pisano Bigelow, Leonardo Fibonacci. And he is considered the most talented Western mathematician of the Middle Ages. Here we have a portrait of him, and it's like the only portrait I see floating around the internet, and it was done in the medieval during some time. I don't know if it was done while he was alive, but this is what we have. Then we have the Leaning Tower of Pisa, and he lived in Pisa, Italy, so absolutely perfect to have the Leaning Tower here. So a brief history of the Fibonacci numbers. In 1202, Leonardo popularized the Hindu Arabic numeral system, numbers 0 and 1 through 9, to the Western world, mainly through his book called Liber Abaci, or the Book of Calculation. Liber Abaci was introduced, it also introduced the Fibonacci number series to Europe. During the 19th century, a statue of Fibonacci was constructed and erected in Pisa, Italy. And there's the statue, the wonderfully handsome statue there. Okay, so what's in Fibonacci's book, Liber Abaci? He introduced the Hindu Arabic numerals 0, 1 through 9, and place value to Europe. So 0, 1 through 9 was applied to commercial bookkeeping, weights conversion, measures, interest calculation, money changing, and more. All right, and then of course the Fibonacci numbers are actually written here and annotated with Roman numerals. So what a relief that he introduced us to the Hindu Arabic numerals that we all use today worldwide, instead of the rather clunky Roman numeral system, which was very difficult to do calculations with. So a big thank you to Fibonacci for that. And of course, a big thank you to the Indians of India who came up with those numbers. So historical significance of Liber Abaci. The Fibonacci number sequence is labeled here Here's a close-up view from the previous slide. The value is shown in Hindu Arabic numerals. The book showed practical importance of the new numeral system, meaning the Hindu Arabic numerals. The book was well received throughout Europe, which impacted European mathematical thought and process. Okay, so the Fibonacci numbers and its relationship with phi. So starting with 1 plus 1 or 0 plus 1, each new number in the sequence is the sum of the previous two numbers. All right, and there's the sequence, and the numbers are all the way up to 610. Of course, it's an infinite number and goes on and on. So the ratios of successive Fibonacci numbers sequence gets closer to phi, and we'll illustrate what that means better here with this slide. Let me just move this over. So Fibonacci numbers approach and become phi. So by dividing a Fibonacci number by the number before it, by the 12th digit, 89 in the sequence, it approaches the golden ratio, 1.618034, etc. And then it gets closer and closer to the exact phi sequence as the numbers are divided up through the sequence. So here are some examples below. So after the 40th number, the ratio is accurate to the 15th decimal place to phi. So 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 2, 1.5. 5 divided by 3, 1.666. 8 divided by 5, 1.6. 13 divided by 8, 1.625. 21 divided by 13, 1.615. So you see the number is approaching the golden ratio. And then by the time we get to, I think it's 55 divided by 89, or rather, the larger number should be 89 divided by 55, we do reach 1.618. Okay, so the use of Fibonacci numbers, past and present. The 6th century AD, Fibonacci sequence was used in ancient India for metrical sciences, or as prosody, used in poetic meter study. Used by Fibonacci to illustrate idealization, rabbit population growth. Used also in idealized cow, called the Dewdney cows, and honeybee populations, called honeybees and family trees. Here we have a nice, lovely picture of an artichoke, which exhibits a nice spiral there. Okay, so more Fibonacci numbers found in nature. So 2 consecutive Fibonacci numbers are found in tree branches. Numbers of leaves on a stem can be Fibonacci numbers. Pine cone, pineapples, artichokes, scale numbers are usually Fibonacci numbers. Not always, but a good deal of the time, surprisingly so. By constructing rectangle set in a spiral formation using Fibonacci numbers as unit lengths, the resulting spiral is very similar to a snail, nautilus, and other shell spirals. All right, so now we'll talk about Fibonacci numbers as they relate to plant vegetation. There's a study called Phyllotaxis. So it's a leaf pattern arrangements or lattice types. So what's the definition of phyllotaxis? It just means plant leaf arrangements on a stem, how they're arranged. Now, the spiral is the most frequent arrangement of plant leaves, classified by the number of spirals called peristiches exhibited. Distiches of parts are arranged alternately in 2 opposite vertical rows. Here we have distiches leaf arrangement in clivia or bush lily. Here we have an alternate spiral leaf pattern here, and a whorled leaf pattern. Okay, so we'll stop here, and I'll briefly turn my webcam back on. So I will see you in lesson number 2.